Hi everyone, we now learn about the power rule for differentiation. Now the power rule states that if a function f of x is equal to some power of x, so I'll say x raised to a power n, then its derivative function f dash of x is equal to n times x raised to the power of n minus 1. This rule is known as the power rule for differentiation. And what it's telling us is that as soon as we're dealing with a power of x, to find its derivative, f dash of x, all we have to do is multiply the function by the power to which x was being raised, so that's n, and reduce the power on the x by 1. So let's see how it works with a few examples. Let's say f of x is equal to x raised to the power of 4. Then to find the derivative, f dash of x, using the power rule, we can state that it's equal to the power to which x was being raised, so that's 4, times x raised to the power of 4 minus 1. And since 4 minus 1 is 3, that becomes 4 times x raised to the power of 3. Another example could be if f of x equals to x raised to the power of 5. Well, again, because this is a power of x, we can use the power rule and state that the derivative, f dash of x, equals to the power to which x was being raised, so that's 5, times x raised to the power of 5 minus 1. And that's equal to 5x raised to the power of 4. Now, what if we have a function f of x which is equal to x? Well, in this case, the trick is to remember that when we write x, it means x raised to the power of 1. And so once more, we can use the power rule and state that f dash of x, the derivative, is equal to the power to which x was being raised, so that's 1 times x raised to the power of 1 minus 1. So that's equal to 1 times x raised to the power of 0. Now remember, x raised to the power of 0 is equal to 1. So this turns into 1 times 1, which equals to 1. Now, in each of these three examples, the power to which x was being raised was a positive integer. But what if we had a negative integer? Something like if f of x is equal to x raised to the power of negative 2. Well, luckily for us, the power rule works perfectly well with negative powers. Indeed, we follow the same steps and state that the derivative function f dash of x is equal to the power to which x was being raised, so that's negative 2 times x raised to the power of negative 2 minus 1. But since negative 2 minus 1 is equal to negative 3, we can go ahead and state that this equals to negative 2 times x raised to the power of negative 3. Finally, let me point out that on top of working with negative integers, the power rule also works for fractions. So for instance, if f of x were equal to x raised to the power of 1/2, or 1 over 2. Then once more we could use the power rule and state that the derivative f dash of x is equal to the power to which x is being raised, so that's 1/2 or 1 over 2, times x raised to the power of 1 over 2 minus 1. Now, since 1 over 2 minus 1 is negative 1 over 2, we can state that this equals to 1 over 2 times x raised to the power of negative 1 over 2. And there we have it. That's how we can use the power rule for differentiation.